Hi, I'm Brett and I'm a financial analyst.
And my name is Trevor and I'm an associate engineer in the functional machinery department, and we both work at Fincantieri Marinette Marine.
One of the first things you might ask if you become interested in shipbuilding like we are is what's inside of a ship that helps it as it moves.
Did you know there can be hundreds of pipes, literally a maze of them inside a ship? They transport fluids that ultimately keep it sailing. Those pipes also have to be cleaned and flushed out so they can stay free of debris.
You've already heard about industrial and non-industrial debris, so how do we remove it before the ship sets sail?
Yeah, we need to prevent any potential systems failures, so this is important.
To remove debris from pipes, we circulate flushing fluid through the system, commonly referred to as segment, via a flushing rig.
What's in a flushing rig?
A flushing rig consists of the pump, valves, instrumentation, and a fluid reservoir. But for it to work correctly, the fluid must be circulated through the system at a flow rate that produces turbulent flow, or the rate needed to dislodge the debris.
Yeah, we want that debris collected in the filters on the flushing rig. So to achieve turbulent flow, let's use some math and let's make you experts in fluid mechanics. The characteristics of the flushing fluid must achieve a minimum Reynolds number of 4,000. The Reynolds number, abbreviated RE, is an important dimensionless quantity in fluid mechanics used to help predict flow patterns in different situations.
To calculate Reynolds number, the following formula is used.
Hey, before we go on, can we talk about that last value, viscosity?
You bet. Imagine trying to drink apple juice, but it slides down your throat like applesauce, or like having to drink a container of yogurt like milk because it's super runny. Yuck. You probably would think there's something wrong with each of these products, and you'd be right. The thickness of a substance is called viscosity.
And viscosity is important for this math problem because it's a fluid's resistance to flow or thickness. Think of a funnel. Water runs through a funnel really quickly because nothing's stopping it. It has very little viscosity. It isn't thick. On the other hand, if you run pudding through a funnel, it may take a little longer. This is because it has more resistance to flow, more viscosity, and is thicker.
What do we use on a ship for flushing fluids? Commonly used flushing fluids are fresh water or hydraulic oil. Note their fluid properties on this chart.
For this exercise, assume the pipes in the piping system being flushed have an inside diameter, D, of 2.209 inches. Using fresh water at 100 degrees Fahrenheit, what flow rate, Q, would be required to achieve turbulent flow in the system?
And question 2, using hydraulic oil at 100 degrees Fahrenheit, what flow rate, Q, would be required to achieve turbulent flow in system?
So now you can see a fluid's viscosity really determines what flushing flow rate is needed to clear debris from a ship's pipes.
Then you can also see that the required flow rates can be adjusted by changing the temperature of the fluid, especially when using oil. What else matters?
The flushing time required is dependent upon the size of the system being flushed and how strict the rules are about keeping the pipes clean. Do the ship's pipes need to be super clean or super clean?
The stricter the cleanliness requirement, the longer the flushing time required. That means the more efficient our flushing processes are, the less time it will take. And you can help us with that. Here's your last task. We give you full responsibility of helping us get the ship ready to sail.
There are 2 steps in standard marine shipbuilding practice. Step 1 is the initial clean. Circulate the flushing fluid through the pipe system segment until the cleanliness requirement is met. Step 2 is a final flush. It is completed in front of witnesses like the customers or military or regulatory authorities so they can validate the results and make sure it's A-OK. This is done by circulating the flushing fluid through the entire piping system segment, volume 20 times or for 20 minutes, whichever is greater.
So we leave you with these final tasks, and if you achieve these, our pipe system will be clean and the ship will be ready to sail.
Assuming the pipe system volume being flushed is 100 gallons and using fresh water at 100 degrees Fahrenheit, how many minutes will it take to circulate the pipe system 20 times? And assuming the pipe system volume being flushed is 100 gallons and using hydraulic oil at 100 degrees Fahrenheit, how many minutes will it take to circulate the pipe system 20 times?
Thanks for helping us today.
We hope you learned that we need mathematicians like you in the shipbuilding industry.